So almost all engineers start working on a feature thinking it is a simple and a no-brainer. But when we start thinking of the implementation details, we realize how complicated things actually are. In this video, we go deep into the email classification service at Slack, whose sole job was to classify an email into an internal or an external one. The feature seems like a cakewalk. But when we start jotting down the implementation specifics, things turn out to be a little more complicated than we anticipated.
But before we move forward, I'd like to talk to you about a course on system design that I've been running for over a year and a half now. The course is a cohort-based course, which means I won't be rambling a solution and it will not be a monologue at all. Instead, a small focused group of 50 to 60 engineers will be brainstorming the systems and designing it together. This way, we build a very solid system and learn from each other's experiences. The course is enrolled by 800 plus engineers spanning 12 cohorts and 12 countries. Engineers from companies like Google, Microsoft, GitHub, Slack, Facebook, Tesla, Yelp, Flipkart, Dream11 and many more have taken this course and have some wonderful things to say. The course is focused on building systems the way they are built in the real world. We will be focusing heavily on building the right intuition so that you are ready to build any and every system out there. We will be discussing the trade-offs of every single decision we make, just like how you do in your team. We cover topics ranging from real-time text communication for Slack to designing our own toy load balancer to ClickBuzz's live text commentary to doing impressions counting at scale. In all, we would be covering roughly 28 systems and the detailed curriculum split week by week can be found in the course page linked in the description down below. So, if you're looking to learn system design from the first principles, you will love this course. I have two offerings for you. The first one is the live cohort-based course and the second one is the recorded offering. The live cohort-based course happens once every 2 months and will go on for 8 weeks, while the recorded course contains the recordings from one of the past cohorts as is. If you are in a hurry and want to binge learn system design, I would recommend going you for the recorded one. Otherwise, the live cohort is where you can participate and discuss the systems and its design live with me and the entire cohort. The decision is totally up to you. The course details, prerequisites, testimonials can be found on the course page arpitbhayani.me/masterclass. I repeat, arpitbhayani.me/masterclass, and I would highly recommend you to check that out. I've also put the link of this course page in the description down below, and I'm looking forward to see you in my next cohort.
So on Slack, we can invite people by email. There are two kinds of people whom we can invite. First is internal, second is external. The difference is that internal people, when you are inviting, they are directly added to the workspace, while external are just added to a few set of channels. Now, depending on whom we are inviting, we would want to trigger an internal onboarding flow or an external onboarding flow, which could be as simple as just showing a different dialog. But with this seems like a very simple statement. But hey, can we not just show them a checkbox when they invite someone? Won't we just show a checkbox that, hey, is this your internal employee or an external person? But you would not want to do that. That would ruin the user experience, like the onboarding flow. Plus, what if someone just wants to what if an organization wants to invite multiple folks in which there are internal folks also, external folks also? You can't just do that, right? So this is where, from a product perspective, it is very essential for you to classify every single email into an internal or an external so that you can show them or take them through that specific dialog boxes, through which you can make onboarding as smooth as possible. Now, this is where we start looking into things and see that such a simple problem statement of inviting people leads us to think from a product perspective and see, oh my God, we didn't think of this case. Oh my God, we didn't think of other case. But you would still say that, hey, if it's an organization, then isn't it obvious that all people of that organization would have the same email domain? So if I have to invite a person with a different email, then that person would be classified as external. Isn't this a no-brainer? It is not. It is not, because there are organizations in which emails are maybe per region. Let's say I'm operating an MNC called bar.com, and I would give bar.in to all the folks who are based out of India and bar.us to all the folks based out of US. Now these would become their email domains, right? There would be a possibility of that. Second is, an organization might also want to classify their interns, their basically contractual employees, their vendors with different email domains so that they could restrict accesses on other set of their internal tools, private infrastructure and whatnot. So now here we see that this is not as simple as we thought, right? Now, given this, we would want to make this process as simple of an onboarding process as possible, which is why we would need an email classification service, right? So how do we go about it? Now here, we go, the way we would want to approach this is through heuristics, like because heuristics would always work. You may very clearly think that, hey, why do we want to overcomplicate things with machine learning, AIs and whatnot? Can we not just apply simple heuristics? So what we are trying to do is, given an email, let's say person A wants to invite person B, whenever a person A types the person B's email address, our email classification service kicks in and it classifies it to be an internal or an external. So depending on which you would trigger the corresponding dialog boxes and the onboarding flow. So here we look at three specific cases. The first one is, like, first two cases are no-brainer, where it's mostly driven by configuration, while in other case we would have to derive the answer. So first is the settings context, because it is very possible that in a workspace, the administrator has configured that these are the domains that are internal while others are external. Or they might have just basically shut down external invites, right? It's very much possible. So if you have configuration that would help you, that would help you do a shortcut evaluation, right? Or a short circuit evaluation of the part that, hey, is it an internal or an external one? You go about that, right? Second is where you go with the inviter's context. So for example, if I would want to invite someone and if my domain is, let's say, bar.external, and I'm inviting someone with bar.external, so which means that we both have same domain. So whatever my classification is, same thing would apply to that person as well. Right? Now this is another simple heuristic that we can apply that would be like almost a surety that, hey, this person also belongs to the same class as the other person. Right? So these two are fairly simple and would cover at least 50% of the cases. But there might still be a chance where there are emails that you are seeing for the first time and you cannot just mark them as external, mark them as internal. And you cannot also probe every time when you see a new email domain, hey, do you want to add it to this list or not? Right? You just want to make the process as seamless as possible, so that, because the more adoption you get, the more revenue you make, the company makes money and we keep our jobs. Right? Okay. Now comes the third case where you cannot derive something out of simple configuration like through settings or through inviter's context. The third one comes as a team's context. Now here what happens is, so now here the challenge is that a workspace can have millions of employees. So Slack does not put any restrictions so long as we give them money or we are on the paid tier. They don't put they typically don't put any restrictions on the maximum number of people we can invite. So workspace may have millions of people. So now, given a query which you sent that, hey, given this email ID, give me the classification if it is internal or an external. Given this, if you have millions of people, how quickly can you identify if this is an internal or an external one? Right? Now this is where the challenge starts to creep in. Right? So now basically we have to find a solution to that. Now the solution to this, as you all might have guessed, and it's pretty straightforward, it's like literally peeking into our eye, is we keep track of all the domains that are part of my workspace and have an aggregated count against which, and we use that to classify, right? For example, if I have, let's say, 4 domains part of my workspace in which I have people whose email ends with bar.com, some people whose email ends with bar.in, and there are a few whose end with gmail.com. Now these are all part of my workspace. Right? I, as an admin, have not gone and basically allowed these sort of emails to be there. You just keep on inviting people seamlessly, and that system would need to keep track of all the count, like the overall aggregation of the number of people against each email. So what Slack does behind the scene is it keeps track of domains in their email classification service. They keep track of domains, and the domains that they keep track of is look like the table looks something like this. For a particular workspace or a team, they specify or they keep a track of domains that they have, the count against them, the date at which it was last updated, and the role of that particular group. Basically, what they're doing is that it says that for a team A, bar.com has 2 people with role admin. Team A, bar.com has 68 people with role member. Right? Now, why roles are segregated here, we will go into it. It's a very nice hack. It's a very nice heuristic that they derive through this. So the idea is, in this table, for every team that they have, they would keep track of all of these things, right? So all of these aggregated statistics. Now, so with this, why do they have to, like, can they not just do it at domain level? Why do they need to add role level information here? They are adding role level information because if the admin is having @bar.com, it's a bigger indication that it is an internal domain. Right? Because admin typically would have the internal domain. So that is why they are just keeping the aggregated count, which is grouped by domain and role for a particular team. Now, these kind of heuristics you can apply when you are building an email classification service. So here, the idea is pretty simple. Given an email, you just see that for a particular, like, you extract the domain out of that email and see where it holds, right? And when you see it, you see what percentage of people and role combination they have the same domain, right? If it is more than 10%, you consider it as an internal. If it is less than that, you consider it as an external. So 10% is a threshold that Slack internally maintains. Like, obviously, it's a tunable parameter. So which means that given this as my distribution, bar.com admin 2, bar.com member 68 people, bar.in member 30 people, and gmail.com member 3 people. So I can see that if I want to classify foo1@bar.com, it would be an internal classification because there are 68 people, right, with bar.com. With bar.in, there are 30. So 30 out of almost 100. It's still more than 10%. Then foo3@gmail.com will be classified as external because there are only 3 people out of 100, almost 100, which are having this particular thing. So you are tempted to classify it as external. Right. So this is a simple heuristic that they went with. A simple high-level architecture for this would look something like this. A user, whenever wants to invite someone, email classification service is triggered. It refers to the domains table in order to identify or in order to classify where this particular email or basically where this particular email sits. Sorry. So it's internal or external. Now, how would this domains table be populated? You might say, hey, it's a no-brainer, right? Whenever a user is created or updated, I keep updating this particular table. So, which is what we exactly do. We consume it. We consume all the events being flushed onto Kafka. We consume it through the workers and keep this table updated. Now, this drawing boxes is easy. But think about it. Imagine, how are you actually updating the table? That is also a very important design decision. Because if you just do count plus plus, would that work? What if that row does not exist? You'd want to make it as simple as possible. So which is where how we go about it is we use upserts in order to add or remove something from this table, or rather increment or decrement something into this table, because upsert statements seamlessly work. So in what upserts are is it either inserts or updates. If the entry exists, it updates. If entry does not exist, it inserts. Now this upsert statement, if you would not have written upsert statement, then you would have to first get, if the entry exists, then update. If it doesn't exist, then you would be inserting onto that. So instead of having that if else in your code wrapped around a transaction, you typically just fire an upsert statement, right? So what you do is whenever a user is created, you file an upsert statement like this: upsert count equal to count plus 1, where team ID equal to 7 and domain equal to bar.com and role equal to member. This way, if entry doesn't exist, it would create that entry. If it exists, it would update the entry to count equal to count plus 1. Right? Now here, the key advantage of using upsert is upsert takes row level locks and the operations are very relative. So it basically solves both the problem in one shot. So even if there are multiple upsert statements firing at the same time, because row level locks exist, it ensures that the data always remains consistent. Now, when you are updating a particular user, a movement might happen is a user is elevated to become an admin. So in this case, what you would have to do is you would have to read when a role changes of a particular person, you would have to have fire two upsert statements. First is where you do count equal to count minus 1. For that same thing, where role equal to member, because now member count is minus minus, while admin count becomes plus plus. Right? Now there are multiple such statements fired, but no matter how many queries are fired, because upsert is taking a row level lock, it is ensuring that the system is eventually consistent, because you are not missing out on anything. Right? And this is very important. Plus, you are not wrapping multiple statements in a transaction which might lower the throughput. So you're still getting enough throughput out of the system. But is it still done? Is it still done? How about this? Are we missing out on something? There is a very interesting challenge that is coming out of this particular thing. And that challenge is a broker that we use that is consuming the events that would be consumed by the workers and updating the database. These broker offer you different kinds of guarantee. No one gives you exactly one semantics, because what they give you is at least one semantic, which means that a message that you are receiving, it is possible that you receive the same message again, because broker thought that its message was not delivered, so it requeued it. And almost all brokers operate with at least one semantics. With this, what is a possibility is that the numbers that you have can drift. Now this becomes a problem, because now let's say if a particular user got created, you updated the entry in the database, but your broker thought that the message was not consumed, or before the message was deleted, the message got requeued again. So then you are doing count plus plus not once but twice. So your numbers, there is a very high chance that they would drift over time. So how do you solve it? Which is where what Slack did is they built a healer service whose job is to periodically heal the numbers and bring it back to a consistent state. But when you do that, an interesting challenge crops up. Now this challenge is what? So first of all, when you trigger a healer service, the healer service is triggered whenever we see a drift. But how do we know that there is a drift? So you apply heuristics here. First, you may think, hey, let me just do it periodically. Let's say every day, one job I run for every team, that would heal the system. Second is when a user upgrades their plan. Let's say Workspace was a free tier and then they change their plan to a paid tier. You might just want to recrunch the numbers and ensure that everything is in place, because their licenses, their billing depends on this. Right? Third is when an email is added for the first time. So when a new email is seen, you would want to just trigger a healing process. Now, given the frequency of this healing process, you would want to ensure that it's lightweight, it's consistent, and it does not make your data go inconsistent. Now, let me walk you through that. And again, it's easy to draw a box around healer and hey, this would heal the system. But how do you actually implement it? Now, a naive approach that you may think to heal is that, hey, let's say whenever a healer runs, I would just recompute the count and update it in the DB. So which means that whenever my healer is running, I'm simply going through all of the users that I have. I'm extracting their email domains, and then I'm doing the count in memory and I'm updating it in the database, which means I'm replacing the domains DB for that particular team. The edge case. The edge case here is so the point when you started your healer, then you computed the numbers, then you crunched the numbers, you got that aggregation, and then you're replacing. Now, let's say this healer took 5 minutes to compute it because there were far too many users. Now, in this 5 minutes, the new users that came in or the new updations that happened, what about them? You would be losing out on that, because then when you replace it, the updates that happen in between are lost because you are doing a complete replacement. So that's not good, right? So there has to be a better approach. So what do? So in that case, the answer here is, again, the upserts operation play a very important role. So what you do is when your healer starts, at that point in time, you keep track of the date time. This is the date time at which your healer started. Now in the domains table that we had a column called date update. Now this is what would tell us that up until this time, this was the state of my database. right? Now you keep track of this, right? So what you do, the idea is pretty simple. When your healer starts, you keep track of the date time. When you have the date time, you start computing. So you first read your domains table. You know that this was the count that was there in my domains table. You go through all the events of the users again up until this date time. So who's updated at is up until the noted date time. You compute the numbers, you see the drift, and you know that, hey, this is what I want to do, plus and minus and whatever you want to do. Again, upsert operations. You will not do replacement. You will trigger upserts. Right? Now with this, what happens is up until this point, the time at which healer started, you knew what the state of your domains table was. That is a snapshot that you have. Second, you went through all the events of user creation, updation, deletion up until that modified time, because you would have an updated ad field in your users table or somewhere like that. You would go through that and recrunch the numbers, find the drift, and you create an upsert operation of plus and minus and whatever your operations are. You would start pushing those things through that same route. Now what happens with this is the new events that are there are anyway being upserted. The existing one, the drift that you computed, will also be applied. So with healer, with this approach, you are ensuring that you are not replacing something. So you are always upserting. This way, you do not lose any events, or you do not lose any updates that you have made on the database. So now the architecture of this looks something like this. Everything else remains the same, and you just plug a healer whose job is exactly what I just described. Right? So from the events that are flowing in, a healer consumes it, and it basically queries the DB, gets the drift, it triggers the corresponding upsert, which happens on the DB, and system eventually heals. So this entire system is eventually consistent. It's not strongly consistent, it's eventually consistent, but it would definitely converge in some time. You may not be sure by when, but you would definitely be sure that it would eventually be converging to the correct state. And this is where I always say the devils lie in the details. And this is where we see we could have just drawn boxes and said, hey, this is the system that we designed. But in reality, when you start thinking of the implementation, you start realizing that it's not as simple as it seems. We could have very easily drawn a healer box and say, okay, this would just heal it. But that's not where the fun lies. The fun lies in the intricate, granular, minute details of implementation. And yeah, this is how Slack does it. All of this is taken from Slack's engineering blog, which I've linked in the description down below. I would highly recommend you to check that out. And yeah, this is what I wanted to cover today. I hope you found it interesting. I hope you found it amusing. Just keep an eye on the details of any system that you are learning. Go through that intricate details of implementation, and that's how you become a better engineer. I would highly recommend you to do that for every single thing that you are studying, right? So yeah, that is it from me for this one. I'll see you in the next one. Thanks, Atal.